All right, let's just jump right in. We are talking about something huge today, and that's the massive gap between what universities are teaching about AI and what the industry actually, needs right now. So in this explainer, we're going to break down why that gap even exists and, way more importantly, map out a totally different path to really mastering this stuff.
And this really gets you thinking, and it's a pretty scary question, right? Is your AI degree basically out of date before you even get to walk across that stage? I mean, with new models and frameworks dropping what feels like every single day, the speed of AI is putting a ton of pressure on the old school way of learning. And this slide, this just lays it all out perfectly. Look at this. On one side, you've got the university reality. You're doing basic PyTorch tutorials, you're learning high-level theory, and you're playing with these tiny, perfectly clean public data sets. But on the other side, this is what companies are actually hiring for. Skills like RAG, that's Retrieval Augmented Generation, Agentic workflows, and knowing how to actually deploy something to production. It's about end-to-end ML ops. These are just two completely different worlds. So, how do we get here? Why does this giant chasm exist? Well, it's not just a few out-of-date classes. We are talking about some really deep, systemic problems that are just baked into the way universities are set up. And honestly, the scale of the problem is kind of wild when you see it all laid out. 22. That's the number. And no, that's not an exaggeration. That's the actual number of distinct systemic barriers that have been identified in most university AI programs. It's a lot. So let's actually dig into what these are, because they stack up in some interesting ways.
So first, you run smack into the infrastructure wall. Most universities just don't have the hardware. We're talking no big GPU clusters for students to use, no free cloud credits, nothing. Students can't even afford the API tokens to run experiments with large language models, which means any real hands-on learning is dead on arrival.
And then you've got this massive skills and knowledge chasm. The curriculum itself can be 2, 3, even 4 years out of date. A lot of the faculty, while brilliant, they just don't have that modern, in-the-trenches engineering experience. So what happens? The stuff that's absolutely critical in the industry right now, ML ops, RAG, agentic workflows, it's just not even on the syllabus.
And finally, students are basically stranded in what you could call a data and practice desert. They get zero training on how to handle the huge, messy, chaotic data sets you find in the real world. They're just using these tiny, clean, little benchmark data sets. So they graduate with no idea about data versioning, governance, or what it's like to build a full-stack project. So you add all that up, and what do you get? Well, the conclusion is pretty harsh. It leaves graduates fundamentally unprepared for the jobs they're actually trying to get. The system is almost setting them up for failure before they even start. Okay, but what if there was a way to just sidestep all 22 of those barriers? This is where it starts to get really interesting. Let's talk about a totally different way of thinking. The CPU-only pathway. This is about getting professional-level skills using nothing more than the laptop you probably have sitting in front of you right now.
So what in the world is CPU-first LLM engineering? Well, it's pretty much what it sounds like. It's a self-guided path that uses all these amazing, free, open-source tools that are built to run on normal computers. We're talking a standard i5 processor, maybe 16 gigs of RAM, no fancy GPUs, no expensive cloud accounts, no API bills.
Let's just put them side by side. The university path, it's expensive, depends on GPUs you don't have, and it's all about theory. The CPU-first path, it uses your laptop, costs basically nothing, and it is 100% focused on practical skills, on systems engineering. The outcome isn't just about being prepared, it's about having deeper, more relevant skills than everyone else.
So, okay, how do you actually do this? It's not just about messing around. This is a structured 6-phase syllabus that's designed to build you into a complete professional AI engineer right from square one. So let's actually walk through the roadmap.
Okay, here it is. You start at phase 0, just mastering the basics. Python, Get, Linux. Then you move on to building your own local setup. Then you learn how to engineer data sets and master some really clever, efficient techniques like distillation. And then the final phases are all about building advanced systems and, maybe most importantly, developing a true product mindset.
And let's just double-click on that one concept from phase 3, distillation. This is not basic stuff. This is a super powerful technique where you train a small, nimble student model to act just like a huge, powerful teacher model. This is how you get world-class performance without needing a supercomputer. You're learning the cutting edge of AI optimization, right there on your own laptop. It's incredible.
And look, going through a syllabus like this doesn't just give you some cool knowledge. It unlocks actual high-paying jobs. You could become an LM application engineer, a dataset specialist, a prompt engineer, even an AI agent engineer. These are the roles that companies are desperate to fill right now.
And now we get to what might be the most important part of this whole journey. It's this final mindset shift. Because this path isn't just about learning to code better. It's about learning to think like a product engineer, to go from tinkering in notebooks to building real, scalable products.
So a key to this is a concept called agentic coding. And this is pretty wild. It's where you use these small local language models almost like autonomous coding assistants. They help you plan features, write the code, test it, debug it, the whole 9 yards. It's a completely different way of building software, and you can do it all by yourself on your own machine.
And that really brings us to the core philosophy here. The goal is to stop building projects for the sake of it and start thinking like a product engineer. What does that mean? It means you're focused on the user. You're building things that are reliable and maintainable. That's the mindset that truly separates a student from a professional. Which, of course, leaves us with one last pretty big question. If this powerful, self-guided, and essentially free path to a career in AI is possible, and in a lot of ways even better, then who is university for anymore? What does that mean for the future of education? Definitely something to chew on.